Okay, now it's recording. So can you move this a little bit further in that direction, Gabriel? Okay, go ahead. All right, so Mr. A1 come here to the position of applying a tectonic strain. Wait a minute, let me explain what's going on over here. So can you go into this direction so everyone can see? So what we're doing here is this handle. What it's going to do is going to move this bottom base up, very similar to what you did in the laboratory, but now this one is manual. This little frame must be probably 100 years old, but still works. And as he moves this bottom up, what is going to happen is that we're going to have this bottom section to go up, and this one is going to stay constant over there. It's not going to move. If you notice what we have over here, we have a sandstone sliced over here on that plane, and we have also put some plastic heat shrink on the side, which is containing the rock not to fall apart in two pieces. This is no glued, no nothing. It's just on top of each other. It's resisting a force just because of friction. Friction between the planes, and there is this heat shrink holding it in the other direction. And what else do we have over here? We have sensors. All of those are P-wave sensors, like something very similar to geophones. And all of those are going with those cables through some amplifiers inside here. Can we open this, Gabriel?
Yeah.
Okay. Are going over here to this device over here, which is a computer which is recording the activity. Do you see those slides that it's going orange at sometimes? Well, let me knock this. You see how I turn them on? That's because those are feeling the movement of what I did already. So what we're going to do now is we're going to start moving this one up, and ideally, what would you expect? Any suggestion?
P-wave.
Okay. Coming from where? No, they don't come from the sensors. The sensors are passive. These are not active sensors. These are all passive. The P wave and the shear wave is going to come ideally from the fault plane, which is that fault plane over there, right? We have a fault to slide, as we have, for example, in earthquakes. The seismic activity will come from that interface. So, okay, Mr. A1, go ahead and just crank that slowly, and then you start to see some points that start to appear over here in the screen, and probably if you look down over here, you will see that all those lights turning on is telling you that there is quite a bit of activity there. And stop for a second, Mr. A1, and you will see that there's still failure, and that's why those lights are going crazy because of all the activity going on there, even though he stopped moving that. And after some time, you see, if we see these plots over here, they tell you all the seismic activity as he was turning that handle. And if we move the mouse, Mr. A1, and just move this in 3 dimensions and try to locate the plane of failure. So now you see, do it very slowly, move it in a way that all those points align. And that should be the plane of failure. No, continue. Maybe, no, it should be a plane very similar to that plane over here. It's well, somewhere over there, you see? You see that all the points now kind of collapse in one plane, not exactly on one plane, but mostly on one plane. So somewhere over there, you see? So all the points coming out from this plane are all the seismic activity which is coming from that plane over there. Any questions? No? Anyone else wants to play with the frame? No? So let me repeat what's going on here. We're sliding those faults next to each other. This is similar to a fault, and as those two slide, there is small failure in here of the grains inside the rock, which is creating all that seismic activity. So probably let's do it one more time. Mr. A1, go ahead and turn the crank, and you will start to see again the light on the bottom to turn on quite a bit, and all of that seismic activity going on into that preferential plane. So now probably you can see a little bit better how all those points locate very close and in just one orientation, which is the orientation of the failure plane. Okay, so you can stop, and now you can see again how there are two peaks. The first peak was the first time that we created all that noise, and the second peak is for the second time. So guys, if you want, just pass around and just take a closer picture so you can put in your report, and later I would like that you describe this experiment on a 1-page or 2-page report, no more than that, including figures. Just very short, telling what is the concept, what is going on, what are those dots, and I'm also going to give you some of the data that comes out of this, so you can plot a graphic very similar to that one, telling you the seismic activity as a function of time.